Hello and welcome back to CQ, our Amazon certified quiz show, here live at Sydney Summit 2019. I've got the fabulous Ash back with me today, which means more machine learning questions, all right? So bear with me as I try and read through them. This is our brand new speciality exam, just gone to market in March, so we do encourage you to have a good look at it. Ash, what type of job roles should be looking at this particular exam?
So this particular exam is applicable for data scientists, data engineers, and anybody who wants to go deeper into machine learning. In AWS, we provide a very extensive learning path for our customers to adopt machine learning from scratch. So anybody and everybody can come and dive into it.
Awesome. Yeah. Reminder for everyone watching with us online, John's here moderating our chat. Please feel free to send any questions to myself, Ash, or John, and follow us online with the poll. Should we jump into some questions, Ash?
Sure.
All right, first question. A data scientist uses logistic, it's gone well already.
0 for 1.
Logistic regression to build a fraud detection model. While the model accuracy is 99%, 90% of the fraud cases are not detected by the model, Ash. What action will definitely help the model detect more than 10% of fraud cases?
Okay, so guys, if you look at the question talks about logistic regression. So always look at the algorithm we are specifying in the question as a quick tip. Now, if I look at the options, we have options of undersampling and oversampling and regularizing the data. Now, all my data science friends out there, immediately you'll ask me, well, what about the bias versus variance consideration? What about making sure that we are able to manage that relationship? Yeah. So if I look at the option 1, 3, 4, I'm able to sample my data, but it doesn't guarantee that I would have the same precision for my model, because ultimately it's logistic regression, which will not kind of impact the accuracy to an extent. So data sampling is not an answer for this. So I am moving more towards option number 2, which is decreasing the class probability threshold. Now, class probability threshold is basically a concept where you as an engineer or a machine learning specialist decide the threshold level of your right answer. So whether this is a fraud case or not, you determine the threshold of the accuracy. So if you decrease the threshold, you have a control over how many cases come under the fraud levels versus the non-fraud levels. And here, if you look at the question, they say the accuracy is high. So I do have 99% accuracy, but still my prediction is inconsistent, which means that I have to fix my probability threshold to get into a level where I can manage my outcome. So I think answer 2 should match the outcome for the question.
How are we looking on the poll, John?
Oh, a little bit for 2, a little bit for 4.
2 and 4. Let's reveal the first answer. 2 it is. Ash wins again. Ready for question 2 today, Ash?
Sure.
All right. You are the data scientist within your research group studying gravitational waves.
Ooh.
Wow.
That's pretty
interesting. I would love to.
New job. You need to build a machine learning model that can predict the strength of gravitational waves based on collected past observations. Which of the following techniques would you use? One answer only, please. Ash?
Okay. So the question actually gives you a use case or a scenario where you are looking at, you need to determine the strength of gravitational waves by some historic data.
And that's quite typical of the way we see a lot of our questions, right?
Exactly. And we do a lot of prediction analysis in our real world use cases as well, like earthquake predictions and gravitational waves patterns prediction.
Okay.
Now, if you look at the options we have, as a data science person or somebody coming new into data science, you need to be very clear about what is the difference between clustering versus regression versus classification. Now, clustering is a non-supervised, unsupervised learning technique, and regression and classification are supervised learning techniques. Now, if you look at the question, we are looking at a pattern for previous past observations, and it's a continuous pattern because you have to determine that for the gravitational waves constantly, right? If you do classification, you would just get a classified answer or a yes or a no or a numerical outcome, but you have to do a continuous analysis for this particular outcome. So classification goes away straight off. Anomaly detection is not just the only thing you would do when you are doing analyzing these gravitational
Sure.
waves. You might want to go further and do other steps. So the closest, I feel, which meets the requirement for this particular use case is a regression technique. And regression is basically we use a lot when we are doing forecasting and predictions, and it works really well because it forms a continuous pattern of doing those predictions. So hence, because it's a continuous analysis approach, so I would go with answer number 3, regression.
John, how's the poll looking?
You have the majority out there, a bit of regression
Yay,
and a bit of
cool.
classification.
And
Great.
the answer is regression. Thank you,
I'm happy
Ash.
that the guys in the poll at least have chosen the right learning technique for that, which is awesome.
Different to the other day. All right, let's move on to question 3.
Okay.
Model evaluation.
Okay.
In the binary classification of evaluated model accuracy in Amazon machine learning, predictions fall into 4 groups based on the actual known answer and the predicted answer. Which choice is not one of those 4 groups?
Okay. So again,
Tricky question. I hate when they put those knots in there.
I know, because that's how they want to trick you and make
Yeah.
sure you are able to read the question carefully. So guys, please read the question carefully and the options.
Tip of the day.
Absolutely. Now, interestingly, if I look at the options, I have heard about true positive, false positive, true negative, and false negative, but I have never heard about minor positive.
Okay.
So I don't think
Go
it
on.
exists. But guys, just for the context, true positives and false positives, as the name suggests, it just tells you true positive means how accurate you're able to predict the correct outcome for the model.
Yeah.
Everything is positive here.
Okay.
And true negative is when you're able to predict the incorrect answer correctly, because you will have to predict the non-linear
Sure.
cases as well in the model.
Makes sense.
So that's how this combination is mapped in machine learning. So minor, major is not even a concept here. So I would just discard option number 3 altogether. So answer number 3 is the answer. Yeah. So the answer is option number
because
3.
It's not.
Yeah, it's not the
Oh,
correct
see, I'm getting
answer.
confused
Yeah.
already by the question. It's
Yeah.
crazy.
So third is not a concept in machine learning.
And
hence
that's why that
that's
is the
why it is the answer.
That makes
John,
it easy.
have they managed to figure it out online?
Yes, we have agreed that that is not the major, the minor.
All right, let's double check we're on the right
Too
wavelength
many
here.
knots here.
Number 3 it is.
But are we sure?
Yes.
Number 3.
Answer revealed.
We have minor positivity over this, I think. so.
There's no concept of
Yeah,
minor positive.
yeah.
Number 3.
Fantastic. We got there. All right. Question number 4.
Oh my. Oh my.
What, you worried
She's
about the
going to
length
have
of
a
the
good time
question?
here. It's a long question.
We've got this. We've got this.
Okay.
All right, Ash, you ready?
Yeah.
A company has customer comments on its products rated as safe or unsafe using decision trees. The trained data set has features, as you can see on screen. During training, any sample with missing features was dropped. In a few cases, the test set was found to be missing the full review field. For this, which is the most effective action to address test data samples with missing features?
Okay. So as I'm going through the options and I'm looking at the scenario, again, guys, feature engineering is very important for machine learning because data is the currency for machine learning, no matter what you do. That's the first step.
Okay.
You have to derive the features very accurately. And it's a real world problem, right? You would not always get all the features available for
Yeah.
you, all the data sets applicable for you. You end up doing lots of sampling just to ensure you're able to predict the right outcomes. Makes a perfect sense. It's a real valid problem. Now, if you look at the attributes which are provided in the question, right? ID, date, full review summary, and a safe, unsafe tag.
Yep.
I can look at the options of, doing synthesizing my data set and enhancing it by adding more
Okay.
on top additional features, but I would not see a lot of advantage compared to if I can find, especially for a text-based field, a field which is kind of similar, but
Okay,
not exactly
okay.
the same.
Yep.
So when I look at the question again, I see that I have 2 fields which could have similar answers, the full review field and the full review summary field.
Do you
So if-
find this is often the case, that information has similar data?
might have, especially when you're doing the forms, where you have multiple fields kind of asking similar questions. So, and in that circumstance, instead of just discarding what you have, just grasp whatever information you have and build intelligence from it. So even if I am able to
Yeah.
fill in the summary field, if I can take that field
Okay.
as a full summary and derive inference or, kind of text analytics from that part, that would help me enhance my feature engineering process. So if I look at the options, yes, I can do other options, like I can build a decision tree, I can build a k-means algorithm and decide patterns to recognize what I can fit in. I can put synthetic words in there to kind of cross-reference what it could mean based on the other parameters, like derived attributes. I can do all that. But if I already have a review field which is giving me an idea of it, the customer might want to say that, why don't I take that away, put that in my text field, and do feature engineering on top of it? So that is the closest option and a logical option I would do when I'm doing feature engineering. Hence, option number 2 seems consistent to me here. So copy the summary text fields and use them to fill in the missing full review text fields and then run through the test set again.
So rather than throwing away information, you're trying to fill it in with other bits?
Exactly.
Because I frequently find when I'm gathering information, people leave fields empty or something hasn't translated across.
Absolutely. Yeah.
And if you were to throw away fields, would it ruin the normal distribution? So it's better to...
It would not ruin it. It will impact your precision of your model, right?
Okay.
Because the more data you have, the more attributes you have to understand how accurate your model is. Ultimately, all of the machine learning conversation is about this thing between we have to increase the bias and reduce the variance. So however data we get, whether features, derived features, variables, all this variable pruning we do, we actually want to make sure we are going towards high bias ratio and low.
To have different...
Exactly.
Right. Right.
And hence having the data more, using it effectively, and not producing synthetic, because synthetic data is also based on you're assuming something. It's not really a real-time answer. So having a real-time scenario will give you better understanding. And we do have a lot of good understanding about doing feature engineering with machine learning. We have lots of attributes about missing text fields, missing numerical fields, how to use derived attributes. So I strongly recommend all of you to look at our AWS docs, feature engineering section to understand the different scenarios possible.
We'll get the links up on the chat.
Absolutely.
Yep. So locking in number 2.
Yeah.
Which online they've actually gone for number 3, Ash.
Number
Do you want to
three,
do a
using an
quick
algorithm?
why
Tell us about the others.
with the decision trees?
Use an algorithm that handles missing data better than decision trees. Well, you can definitely do that, but again, it comes back to you will have to build that based on your features, right? You would not have that available, and that algorithm you produce is going to, it depends upon what you use. What technique you use to build that algorithm can impact the feature engineering process.
Yeah.
So again, it comes back to, I already have my data with me. Why can't I reuse that data and build up my asset than just trying to build an algorithm, which I can definitely do by k-means or other classification techniques. But that's an additional work I'll have to do, but with no guarantee that I would get the right outcome.
Has she changed people's mind
online? We have a
online?
question here, the synthetic data mentioned in number 4. We have Piotr asking, is that random data?
Synthetic data to fill in the fields that are missing data. No, it's not a random data. So behind the scenes, what we can do for synthetic data analysis is we use a technique called as SMOTE, which is taking up the minority scenarios, SMOT. And what we do basically is produce, use algorithms like k-means or other classification algorithms or clustering algorithms to define the behaviors and the boundaries of what might match the outcome. Not exactly the same, but what might match the outcome. So those won't be random values, but would be kind of bounded across or clustered across the particular attribute you have.
I will believe you.
So
Awesome. Shall we reveal the answer, John?
The answer is...
2 it
2.
is, Ash. Thank you so much.
And we confused the audience there. That's excellent. Maybe it was those knots that confused them.
No knots in that question.
Do we have time for one more?
Let's speed through this last question, Ash. We've got 2 minutes left, okay?
Okay.
Throw in a question on algorithms. As a data scientist, you have a data set that contains several important features. You're required to perform cluster analysis on it to search and find groupings of similar records. Which machine learning algorithm will allow you to perform the required analysis?
No pressure, 1 minute.
The answer is in the question itself.
Awesome.
So because they're talking about clustering, out of the algorithms I have here, logistic regression is a regression algorithm. K-nearest is a classification algorithm. Naive Bayes is more about probabilistic classification. So the only correct answer which does clustering here is
Obviously
k-means.
is k-means.
So k-means is the answer.
And what is K-means?
K-means clustering is an approach where it's an unsupervised learning approach where you can actually cluster your data with similar attributes together because you don't have a labeled data set, it's an unsupervised aspect. So you want to group your data in a particular similarity features, and that's what you do by using K-means clustering. Cluster your attributes together.
I think I know what you K-mean.
Thanks, John. And
Cool.
the answer is indeed K-means.
Cool.
Ash, thank you so much for joining me
Thank
again
you.
today. Always love spending time with you. Everyone, stay tuned for some more awesome talks coming up later
Thank
on
you.
Twitch Live. Thank you.
Bye-bye.